This video describes some of the properties of hydrocarbons. Hydrocarbons are nonpolar because they contain no lone electron pairs. Since the molecules are nonpolar, there are only one type of intermolecular forces. These are the London dispersion forces, which are very weak. Hydrocarbons are all nonpolar, so they are not soluble in water, but they are soluble in other nonpolar substances. This is why oil does not mix with water. The weak intermolecular forces also result in low melting points and boiling points, though the temperatures of melting and boiling can vary depending on the length of the parent chain and the amount of branching and saturation of the molecule. As the length of the carbon parent chain increases, there are increasing amounts of London dispersion forces. These increases result in higher melting and boiling points. This is why some hydrocarbons are gases, like propane, which is used to fuel barbecues, while some hydrocarbons are liquids, like octane, which is used to fuel cars. Some hydrocarbons with really long carbon chains are even solid at room temperature. Here you can see the increasing melting and boiling points that are observed as the chain length increases. The amount of branching on a hydrocarbon can also affect the melting and boiling points. Straight chain hydrocarbons have stronger dispersion forces and therefore have higher melting and boiling points. Branched hydrocarbons have weaker dispersion forces and therefore lower melting and boiling points. Having unsaturation or double bonds can also impact the melting and boiling points. Any molecules with double bonds do not pack together well, and so they have lower London dispersion forces than alkanes. This results in lower melting and boiling points in alkenes than alkanes. Please complete the November 8th quiz.